Today, geometry, we are going on to CO46 today, which is talking about a rhombus. And a rhombus is a type of parallelogram, but it's a subset, right? There are those 5 things that we talked about in the last objective 45 that is true for all parallelograms. So each of these 5 things we know is going to be true for a rhombus also. And what are the 5 things? What is true for every parallelogram, which by default makes it true for a rhombus as well? Those 5 things we talked about in C45. Yeah?
Both pairs of the opposite sides are congruent.
Okay. Both pairs, and I'm just going to abbreviate this, but opposite sides are congruent.
What?
Opposite sides are congruent. What is another one? Yeah.
They have like vertical angles, right?
Not within a shape. Vertical angles happen when 2 lines intersect and they're opposite angles. We do have something with opposite angles, although in this case, in a parallelogram, the opposite angles would be like there and there, right?
Is it 360 degrees though? Is that one?
Within a parallelogram, yes. It wasn't one of the 5 things we talked about in CO45 though, the properties. Folks, I'm going to start sending people out in the hallway that just continue to distract themselves and others and myself. Okay? So 360 degrees is true for every quadrilateral, any 4-sided shape, whether it's a parallelogram or whatever. We're talking about those things specific to a parallelogram, which we're then going to go even deeper and talk about what's specific to a rhombus. Okay? In the whole grand scheme of things, and you don't have to write this down if you don't want to, but the general 4-sided shape family, anything is called a quadrilateral, right? And that includes things like, this, right? That's a quadrilateral, any 4-sided shape. So under quadrilaterals, we have a specific set called parallelograms, right? And those parallelograms all have the same 5 characteristics that we talked about in CO45. Within parallelograms, then, we also have a subset of a rectangle, a subset of a square, a subset of a rhombus, and those things are what we're going to start to dive into now. So we're just getting more specific. 4-sided shapes, parallelograms, and within that family is a rhombus. But we're starting with what's true for all parallelograms. Damien.
It has 4 sides.
That's true for all quadrilaterals. Okay?
What?
And it's literally on the page right before this one. Like we did it yesterday. Ellen, opposite angles are congruent.
Did you just write that? Oh, angles.
Okay, opposite angles are congruent. What's another one? Sophie. Consecutive angles are supplementary. Okay. Another one, Anthony.
Diagonals of the parallelogram will bisect each other.
Diagonals bisect each other. And the last one, Aiden?
Opposite sides are parallel.
Opposite sides are parallel. Okay? So those 5 things are true for a rhombus, true for a rectangle, true for a square. So the question is then, what separates a rhombus from the other 2? Because if all 3 of those shapes have all these 5 things, what makes a rhombus special? Now, Jeff.
How come a 4-sided shape equals to 360 degrees, but a 3-sided shape equals 180?
Because if you remember what our formula is, our formula for the sum of the interior angles is 180 times n minus 2. Basically, however many sides your polygon has, every time you gain a side, you're gaining 180 degrees. Okay? So a 5-sided shape has 540 because 360 plus 180 is 540 and so on and so forth. That's 720. Go on. Yeah.
What separates a rhombus from other parallelogram?
Yes. What separates a rhombus from? And it's half cut off here, but there's a rhombus down below here. Okay. Maybe you already know what some of the characteristics of a rhombus are. But Anthony.
It has two sets of parallel sides.
So is a rectangle.
Oh yeah.
So is a square. Max.
They're like not 90-degree angles in the corner.
Okay. It has to do with that. That's not specifically. But talking about that one. The diagonals bisect each pair of opposite angles.
What?
The diagonals bisect each pair of opposite angles. So in a rhombus, I'll draw one in full up here. Okay.
Guys, stop laughing.
Are you trying to read my handwriting?
No, I'm just
Fascinating.
focusing on what it is.
Yeah. So the diagonals bisect each pair of opposite angles. The diagonal that we can draw there, it's going to bisect that pair, which makes these sections all congruent. Okay. Then the other diagonal, which would go from here up to there, it's going to bisect each pair of angles there, making each set congruent there as well. So think about, at the beginning of the year, I told you, geometry is a whole bunch of terms. It's like another language. And if you haven't been keeping up, Damien, with what those terms mean, this is going to start to catch up with you. Bisect means it divides into two congruent sections. You can bisect an angle bisector, right? You can bisect a side, right? And then opposite, in the case of a polygon, means angles that are opposite each other. A diagonal connects them, right? So the diagonals bisect each pair of opposite angles. Those marked angles are congruent there. That's one thing that separates a rhombus from a rectangle and a square. What's another thing? What else do you know about a rhombus? Maybe you're unfamiliar.
Kite.
What's that?
It's a kite.
Kite's different, actually. Kite is a quadrilateral that's not a rhombus.
Kite's a
It's
shape.
got four sides.
Kite is a shape.
What is it?
Again, Damien, all quadrilaterals by definition have four sides.
What's
Yeah,
a
but
kite
so
then?
does this one.
Yes, but we're talking about specifically what separates a rhombus from a rectangle. A rectangle has four sides as well. A square has four sides as well.
Rectangular has long sides, not short sides.
Okay? So Damien said a rectangle has long sides and short sides. That's true. What's true about a rhombus?
Kite's a shape.
All sides are the same.
But I was on track.
That's the same as a square.
Squares have those.
Well, that's why a square is CO48. We'll get to squares. So in a rhombus, all sides are congruent. A rhombus is like if you took a cube of Jell-O and you shook it, and you took a picture of it when it was like shifted over. A rhombus is essentially a square that's been shifted. Okay. Well, Jell-O can move, back and forth, right? Third thing that separates a rhombus from a rectangle or square. Arlene.
I just want to clarify something. So a rhombus is a square shifted and a parallelogram is a rectangle.
Exactly.
Okay.
Yep. It's if you had a prism of Jell-O and you shook it and you took a picture where it was shifted over, that would be a parallelogram.
Yeah.
I said that about a rhombus and a square. It's the same is true for a parallelogram.
Okay,
And
I don't know what this is, right? But is it that, like, where the center of the figure is on the
Very, very close. What Ellen asked is the center where the diagonals intersect, are those sections congruent sections? No. Well, that's true. That's true for all parallelograms, but it does have to do with the center. Where those diagonals intersect, the diagonals intersect at a 90-degree angle. The diagonals intersect at a 90 degree, which means that these four triangles inside the rhombus that we formed with the diagonals, what type of triangles are they? Right triangles, which you can bet things like Pythagorean theorem, 45, 45, 30, 60, sine, cosine. This is where, that's why the entire unit, last unit, was all POs. Because they come up again in quadrilaterals because of the properties that these quadrilaterals have. Okay? Yeah.
I think I speak for all of us when I say, Mr. Olenk should get one of these binders because he looks like he's focusing intently and he needs a binder.
Did I give you one?
No, you have to give me.
I told you.
I should. Thank you. Yeah, Damian, I wholeheartedly agree. I don't have any extras.
Way to look out for
yes,
Damian.
I will get you a binder.
Look out for
You
Ed.
should say that the diagonals are perpendicular.
The diagonals are perpendicular. Yes, that would be another way to say it. However, based on knowing what terms mean, I was nervous of using that one. We'll get to squares. Squares are like the super quadrilateral. Okay. Let's.
So is the second one squares later.
You're right. Yeah, you're right. You're right.
So is the first
Okay. Armed with this knowledge.
what knowledge? It was the third one.
I
I
feel
did.
very dangerous.
What is
You're just missing stuff, man. You're
Lock in,
not
Jim.
paying attention and you're missing things.
I feel dangerous.
Okay? Armed with that, you have enough math knowledge in your toolbox to answer all of these questions about the rhombus, only being given that DE is 8 and that angle EAB is 53. Okay? Let's start with
Wait, which one's 53?
angle EAB. This one right here. Okay? Let's start with the first one. What is angle DAC? And tell me how you know. Catherine. And how did you get 106? Exactly. Okay? Knowing that that angle is bisected, that 53, that the angle is here is going to be the same thing on the other side. These two angles are congruent because one of the properties that we talked about above is that the opposite angles are bisected, right? Not knowing that, you might not be able to calculate what that angle is. That's why all these things are going to be important, okay? What's that? It's 106 because each angle, what the diagonal does is it bisects the angle, right? It divides it into two congruent sections. So this one that's marked as 53, that's going to be congruent to this angle here.
And then combined is
Because, oh, my bad. Sorry, I did DAB. You're right. 53. 53.
Yeah.
53. DAB would be 106. DAC, this one here is going to be congruent to that. Sorry. Lexi. Sure. DB, Lexi says is 16. She is correct. DB, because one of the properties of a general parallelogram is that the diagonals are bisected. This section is going to be congruent to that one.
Oh, it's 16.
And so it's going to be 16.
Yes.
Come on.
Because one of the properties of
Oh, that's
a
an A,
diagonal.
not a B. I thought that was a
It
B
was
too.
like a, I thought it was a B.
On our paper.
On our paper.
Oh, okay.
I have a question.
Where's their B?
Folks, Dan,
I lost my calculator, and I was just wondering if everybody could like look at the calculator. Mine says Dame time on it, so I'm not even kidding. Like it says Dame time on the back. So
I believe it does.
It's a blue
I'll look
one.
at
I believe it does.
Does it say Dame time on it?
Beckman,
Fine. That's next.
B, what color was it?
hey, folks, you're looking for game time.
Dame time
That's what they're looking for.
or Dame Dollar. Either of the two. Dame Dollar.
Beckman, angle AED, what'd you come up with? And how'd you get that? One of the thingies says that they intersect at a 90-degree angle. Okay, so AED has to be a right angle 90 degrees.
Wait, what is?
How? I was like actually paying attention.
Is this intersects on-
One of the properties.
I just don't get like how like AED equals that middle one right there.
Because the middle
So
one is the top of the
AED, the middle letter is the vertex of the angle. The
Every
first
time?
letter,
So you're saying
oh man, CO1 coming back at you.
that's crazy. I
No,
did
no,
not
it's
know
not.
that.
It's just CO1.
I've been
No,
tricked this
it's
whole time.
Not tricked, just
What's the other one? What's your
The AED. I didn't know. You could have said angle E.
no, because there are 4 angle E's.
They're all
There
the
are
same.
4 angles with a vertex of E.
They only hold 90
They do. That's true.
That's
That's
crazy.
true. But the things cannot be specific.
I actually didn't know that. That's crazy. How easy is this?
You can say it's smart.
Can I guess the next one?
You may not guess the next one. You can calculate the next one. But I'm actually going to let you break into groups and finish this out.
Hey,
Show all your work.
Damien.
Dave doesn't